Hey guys, so this is me, Shivam Bhatt, and today I'll be starting off with a new series where, like, I'll be posting a DSS solution daily. So this is something that I want to be committed with uh, from now, and today is day one for this series. I'll be working on towards. So our very first problem today here is two sum problem, which is a really beginner friendly question in lead code, and like it is quite easy until or unless you aren't familiar with the syntax of your preferred language. So I'll be using C++ throughout this series, and let's go and move forward learning about this problem. So as you can see, here's the problem in front of us. You can just read the problem here. Given an array of integer nums and integer target, return indices of two numbers such that they add up to the target. This is there. And there might be there will be one exact solution. Exactly one solution will be there to the problem. So what problem states is, let us take this array 2, 7, 11, and 15, and the target is given to us as a 9. So we will be provided with the target. So we will be provided with an array, and then we will be provided with a target. So what we need to do exactly? We need to find two such numbers from this array A and B whose sum is equal to the target. This. So we need to find two such numbers inside this array to whose sum is equals to target. Right? It's pretty straightforward. We can obviously use this equation for an advantage. The very first approach to this problem is iterating throughout the array. It is the brute force solution. It is the brute force solution, which states that we want to iterate through the array I and j with pointers I and j. We will be checking out every other combination, every other pair inside this array through this nested for loop, in which, yes, through a nested for loop within which we will be doing some stuff here. Okay, and the stuff will exactly be this, which is like if we have got b, then a equals to t minus b. We will be looking for this equation, and if we find a number such that a exists, then we will just finally return it inside the for loop itself, and then we can have something else in the return statement as -1, like a dummy return statement at last. So let's try to implement this solution, whatever I was just telling you about. So let's start with it. We will take size of the array. Yeah, we have taken size of the array. Now nested for loop. They will start from I plus 1. What am I doing here? So what we will do is we will like just declare, let's say, b here. We will declare a number num here, and Now if ARR of if nums of j if nums of j is exactly equals to target minus nums of I. So if this condition is fulfilled, then we can say that we have got our solution. So we'll just have to return the indices, right? So return, we can have uh, something like this to return values. We have to return indices, so it will be j and I. We don't actually need this to, we can just then have a dummy return statement over here, which will not run if we have a solution, but if we have a solution, but if like we will always have one solution as per the question, so it will most likely not run until we have some errors with the code. Okay, so our code is finally running. We can submit here, and yeah, so the time complexity of this solution isn't that good. So now what all we will be focusing on is the little optimized solution, right? We will have the second approach, optimal. Yes. So before learning about this optimal approach, should have we should have an idea about something known as hash map. Hash map. So a hash map is a container uh, in which we will store elements in pair, in a key value pair to be exact. And one good thing about this hash map is that search we can search elements inside this hash map in a constant time complexity of big O of 1, right? We can just do it. So searching is very efficient in hash map, because of which we will be doing it. So what are we actually doing here? The brute force solution was focusing on looking for every other combination inside the array, and that combination was to be explored by these for loops. Now these for loops, the entire goal of these for loops was to find a such number which would satisfy this given equation, right? It is searching for an element. So now if we trim down this big O of n squared solution, which is entirely based on searching, if we search for an element a such that t minus b exists, then if we like create something like that where we don't actually need to waste our time searching for all these elements like this, we can actually trim down our time complexity of the solution to big O of n. Like we will have just a single for loop, big O of n, right? So we'll be using something known as hash map, and I'll be telling you how to implement it right now. But let me just give you an overall what we will be doing. So we will be creating a hash map, a container like this, in which we will have elements. Maybe say we have an array of 2, 5, 11, 15, whatever. So we have these elements. We can store these elements according to their indices. Like at 0, like 2 is at 0th index, 5 is at first index, 11 is at second index, 15 is at third index. So we can store these elements like this. And after storing elements, if we find like if there exists a number, like inside a for loop we are going through, wait a minute, inside a for loop we are going through 5, 11, 15. Let's say we are here, we will be taking this number. Now target minus 2, maybe let's say target is 20. Now 20 minus 2 is 20 minus 2 minus 2 is 18, right? So can I will look for this number, I will say, I will ask this hash map, do we have a key, this is a key, do we have a key which is having value 18? No, we don't have that. It will tell me no, in a constant time complexity of 1, so that my time will be reduced. So if it will tell me that we don't really have this number, we will just look forward to the second index. We will just look forward to the second index. We will say target minus 5, 20 minus 5, 15. Do we have this number inside the hash map? Yes, we have at index 3. So what we will be doing is we will be um, we'll be exploring that key within the hash map. We will say map of key is 15. So what value do we have here in map of key? We have 3. We will take this value 3 and we will take the indices of this value 5, which is the index of this value is 1. We will return the solution as 1 comma 3. So this is the approach of this problem, and let's now focus on the implementation of this problem, right? So now we will be solving this problem with our second approach. We can just remove this. All we need to do is add a hash map. We will have a pair of elements. Yes. So now if um, if map or map dot find, it is a function which we use to find elements. Map dot find, if it is not equal, if map dot find of nums of I, we look for a target, right? We will look for int num equals to target minus nums of I. Now we will say map dot find num if it is not there, map dot end. So what happens is, in a hash map, if I am saying like, if I was looking for number 18 inside the hash map and I'm asking hash map, do we have this value? If we don't have this value, hash map will point towards an like end of the hash map. It will be like a place where null value would exist, something like that. So if map.find num exists in the hash map, what we are essentially asking here is this: if it exists in the hash map, then we would use this value, uh, let's say return map of num comma I is the index, and we will be storing so here we will be storing elements in the hash map of nums of I will be stored with their indexes. I guess this is a solution. Let's say if it is running. Yeah, it is running successfully, and this is our solution to this problem. Yes, it beats 57.14% of people. This is fine. This is a really good solution. And after this, we are ending our first day of code here. So thank you guys for watching, and I the reason why I'm making these videos is to thank you guys for.